Hey, hi everyone. In the previous class, we discussed the basic networking concepts. Now we are entering one of the most important topic in CCNA is switching. In this class, we are not going to learn switching only theoretically. For every concept, I will show you the practical behavior using a switch and pieces in the lab. By the end of the video, you should understand the exact what happened inside a switch when one PC communicate with another PC. By the end of this video, you should clearly understood what is a switch, layer to switching, MAC address table, how to switch learn MAC addresses, frame forwarding, knowing unicast, unknown unicast, broadcast, multicast, collision domain versus broadcast domain, basic switch CLI comments, I mean small CLM comments, just little bit of comments, not going deep today. Complete practical lab. I mean, I will told that lab setup also. So let's see. First, what is switch? A switch is a networking device mainly used to connect multiple devices within a LAN. In traditional Ethernet networks, a switch primarily operates a layer 2, that data link layer. The most important thing a layer 2 switch uses for forwarding decisions is the MAC address. సో సింపుల్గా ఏంటంటే స్విచ్ అనేది ఒక రెండు డివైజెస్ని ఏవైనా రెండు నెట్వర్క్ డివైజెస్ని కమ్యూనికేట్ చేయడానికి యూజ్ అవుతుంది అనమాట. అది కూడా విత్ ఇన్ ద లోకల్ ఏరియా నెట్వర్క్, అంటే సేమ్ నెట్వర్క్లో ఉన్న రెండు నెట్వర్క్ డివైజెస్ని కమ్యూనికేషన్ చేయడానికి యూజ్ అవుతుంది. మనకున్న 7 OSI లేయర్స్, it is for layer 2. I mean it uses the data link layer. So I mean ఫార్వర్డింగ్ డెసిషన్స్ కూడా మ్యాక్ అడ్రస్ని బేస్ చేసుకొని తీసుకుంటుంది స్విచ్ అనేది. సో స్విచ్ అనేది కంప్లీట్గా మ్యాక్ అడ్రసెస్ మీద బేస్ అయ్యే వర్క్ అవుతుంది. స్విచ్ ఈస్ కంప్లీట్లీ లేయర్ టు డివైస్. గాట్ మై పాయింట్? Now look here. Here PC1, PC2 are connected to the same switch. That switch receives the Ethernet frames and decides where those frame need to go. I mean simply, if PC1 send a data, the data was called in switch say it's a frame. So PCA sends a frame to this switch sends that same frame to PCB. So a layer 2 switch forwards Ethernet frames based on the MAC addresses. So switch one knows, this switch knows that the PCA MAC address and PCB MAC address. So if you send any data PCA to PCB, it's know that data where to go, then send to there. If you have one more PC means that PCA sends to PCC, like PCA send to PCC. I mean it won't send any data to PCB because it's switch is intelligent, so it's know the మ్యాక్ అడ్రసెస్. సింపుల్. ఇప్పుడు స్విచ్ అనేది ఇప్పుడు పీసీఏ నుంచి వచ్చే డేటా ఫ్రేమ్ని పీసీబీకే పంపుతుందంటే, సో దీని దగ్గర ఆల్రెడీ మ్యాక్ అడ్రసెస్ ఉంటాయి. సో పీసీఏ మ్యాక్ అడ్రస్ సెండ్ చేసేటప్పుడు ఆ డేటాని మనం పీసీసీ, ఇక్కడ ఇంకా ఎక్స్ట్రా ఒక పీసీ వచ్చింది అనుకోండి ఎగ్జాంపుల్, పీసీసీకి పంపాలనుకుంటే అది పీసీసీకి మాత్రమే పంపుతుంది, పీసీబీకి పంపదు. సో స్విచ్ ఈజ్ ఇంటెలిజెంట్. మీకు ఇంకా before going deeper, sorry, before I going deeper, explain why switch replace hub. So see first, I mean a hub does not intelligent understand the destination devices. It basically repeats the signals to other ports. అంటే wait a second, సింపుల్గా చెప్తాను చూడండి. ఇఫ్ పీసీ, ఈ పీసీ వన్ నుంచి పీసీ టూకి పీసీ త్రీకి, ఈ పీసీ వన్ నుంచి వచ్చే డేటాని పీసీ టూకి పంపుతుంది, పీసీ త్రీకి పంపుతుంది హబ్. కానీ స్విచ్ అలా కాదు, స్విచ్ ఇంటెలిజెంట్. సో ఇప్పుడు పీసీ వన్ నుంచి వచ్చే డేటా ఫ్రేమ్ని పీసీసీ కావాలనుకుంటే పీసీ త్రీకి కావాలనుకుంటే పీసీ 3కి మాత్రమే పంపుతుంది. పీసీ 2కి కావాలంటే పీసీ 2కి మాత్రమే పంపుతుంది. Because a switch can learn which MAC address exists on which port and forwarding the frame towards the correct destination. Just a simple thing. So I mean switch knows which MAC address need to send which port. I mean it's get that information from F01/1 means it's know for some data, this PC1 data need to send into PC3. Now then after it's send that frame data sends to PC3. Simple అబ్బా. ఇప్పుడు స్విచ్లో ఇప్పుడు హబ్లో అనుకోండి, ఈ PC1 డేటా పంపేటప్పుడు ఆ PC1 డేటాని PC2కి పంపుతుంది, PC3కి పంపుతుంది. సో దీనికి తెలియదు దేనికి కరెక్ట్గా పంపాలి అనేసి. కానీ స్విచ్కి వచ్చేసరికి అలా కాదు, ఇది మ్యాక్ అడ్రసెస్ని లెర్న్ చేస్తుంది. సో ఈ PC1 అనే మ్యాక్ అడ్రస్ లెర్న్ చేస్తుంది, PC2 మ్యాక్ అడ్రస్ లెర్న్ చేస్తుంది, PC3 తాలూకు మ్యాక్ అడ్రస్ లెర్న్ చేస్తుంది. ఇప్పుడు నేను PC1 నుంచి PC3కి కమ్యూనికేట్ చేయాలనుకుంటే ఇక్కడ నుంచి డైరెక్ట్గా అది మరి PC2కి పంపకుండా PC3కి కమ్యూనికేట్ చేయాలనుకుంటే మధ్యలో ఉన్న PC2కి పంపదు, డైరెక్ట్గా PC3కే పంపుతుంది డేటా. సో PC3 నుంచి PC1కి మనకి డైరెక్ట్ కమ్యూనికేషన్ వస్తుంది without disturbing. So now next, what is MAC address? Already you know, in my previous short videos I will explain that detailedly, but some briefly I will explain today. What is MAC address? MAC address stands for media access control. It is a layer 2 address associated with a network interface. I mean, in every PC or any network device it has one NIC card. So that network card has a permanently fixed one physical address. That physical address is a MAC address. So if you look here, it is the example. For example, I take in this example, it has a 48-bit address usually represent in hexadecimals. Hexadecimals means 1A, 2B, 3, that more than after 9, then it's hexadecimal number. User from layer 2 communication, sorry, hexadecimal means 1 2 3 4 5 6 6, that's why it's called hexadecimal. Used for layer 2 communication. Switches uses MAC address for the frame forwarding. I mean switches using the MAC addresses to send the data from one frame to one port to another port, or one PC to another port. You can see in our my PC MAC address also. Wait a second guys. See, these are all physical addresses. These are all MAC addresses. Look at here, hexadecimals. Okay, this is MAC address. Depends on this MAC addresses. Switch forward the frame from one PC to another PC based on that destination MAC address. Got it? Hmm. Simply don't confuse them. Simply just remember one thing. IP address means it's completely layer 3 packet. MAC addresses mean is completely frame. Just a second, wait, I will write here. I just IP address is completely layer 3, so it's called packet. MAC address, it's layer 2, it's called frame. So remember this thing guys. If any interview question there also asked like that, switches uses which one packets or frames, you just told that thing. Okay, just remember, just identify purpose only. I mean IP address is completely layer 2, it's called packet. I mean that IP address is forwarding from one device to another device, it's called packet. But MAC address is completely layer 2, it's called frame. Okay. Then gonna start a small practical lab. Now for simple lab purpose, you just download the Cisco switch, the Cisco packet tracer. Wait, I will explain that one also, how to install Cisco packet. Okay, here it is, Cisco packet tracer. Click here. Why I was a suggest for Cisco packet for beginners? Because it is the easiest way to download and access and everything it has. No need to take more time for beginner purpose only. If you are more experienced means you go with the EVNG or GNS3. That one is good for you. Okay, just log in with your, just log in with your Cisco credentials. Then resume that course. You get here download Cisco packet tracer, then click this URL. You will redirect you to that Cisco official portal. I mean, now you can see here packet tracer. This is for Mac OS, this is for Ubuntu, this is for Windows. For you who have that low configuration like 8 GB RAM, i5 processor, i3 processor, they can easily utilize it. You can use 4 GB RAM laptops also, it can easily access and everything. So my suggestion is, if you, anyone beginner means, you go with the Cisco packet tracer. Do labs guys, if you do lab means that's enough, no need to go somewhere to learn more things, just beginner purpose. I'm not talking about any network engineers already working there means. Beginners, you just learn this thing means it is enough. For if your recruiters also, they know how that knowledge is enough for that networking roles. Okay, already I installed. Just click there means you can download it. Click here, automatically it will download. Okay, already I downloaded, no need. Now I just do one small lab just for MAC addresses, understanding how that MAC address frame from travel in switch, how switch learn MAC addresses, that under I will explain. It's just a small lab. Huh? What happened? Okay, now I got access. Yeah, just a second guys, my mouse. Okay, this is switch. Go to switch, take one switch, place here. Just see, I will finally I will explain this lab also. Take two pieces. Here one, here one. Connect the LAN cables. This LAN cable already you know. Cat 6 LAN cable through RG45. In every PC has one NIC card. There you connect here, and switch side connection already you know RG same like for Ethernet ports. That ports you need to connect there. Then it will communicate from here to here. I'm not give any IP address to switch. Just for communication purpose, I give IP addresses. 192, 168. Tell me that 192 is which class? Yeah, correct. Here we can give 1.20. 1.20. That's why I called default classes. I explained also this thing. You no need to give. Just enter means it will take all default. But it depends on first octet. You got my point? Okay, now just go to command prompt, then ping 192.168.1.10. Look at here, it's get pinging. See, now you understood. Ping uses ICMP protocol. It sends frames that under different concept. Just for normally knowledge purpose I told, just you use ping command. This is ping command. Now you ping whatever it is, IP address 68.1.10 given means it's go ping. Okay, this ping is successfully, but not the important question is how did the switch know where to send the frame. Same question you also have that, the means that's called MAC addresses. It's already this under I explained in our table. Now look at in switch CLI. First enable it. So MAC address. So MAC address table. Look at here. It's already learned that PC1 MAC address. Look at here. Wait a second. Oh, I will decrease this. Mm, Look at here. Simply. So PC1 I connected in FA1 slash 1 and PC2 is connected in FA, sorry, PC1 connected uh, PC1 connected in F0 slash 1, PC2 connected in F1 slash 1. Simple. So this MAC address are populated. So it can go through switch, then switch save that MAC address into this connected port. I mean this which port was connected here, that port it saved with this PC MAC address. Then after second MAC address also save like that. You can watch there. I explained already in ARP table how ARP request sends and received. There you will get this all information. How switch knows that PC1 to PC2, how that ping was happened before. I mean before itself it don't know that PC1 to PC1 to PC2 MAC addresses how they get. So PC1 has it if the destination MAC is broadcast MAC address, this broadcast MAC address is FFFFFF, then after that switch broadcast to all ports that populate that under I explain in our class. In my videos you have it is there, you just go and watch it, that you can understand very well. I explained completely here, just you understood that MAC that switch learn the two pieces MAC addresses, it will save in her own MAC address table. Okay, switch in own MAC in that switch, I mean simply switch అనేది తన లోపల మ్యాక్ అడ్రసెస్ని సేవ్ చేసుకొని ఉంచుకుంటుంది మ్యాక్ అడ్రస్ టేబుల్లో. సో తర్వాత మనం ఎప్పుడు పింగ్ చేసినా దేనికి పంపాలి అనేది స్విచ్కి బాగా తెలుసు. ఇప్పుడు ఇక్కడ మూడో పీసీ ఉన్నా, సో PC1 నుంచి PC3కి పెడితే మరి PC2కి వెళ్తుంది, డైరెక్ట్గా అది PC3కి మాత్రమే వెళ్తుంది. సో దట్స్ ఇట్. It's a simple app, just understanding purpose I told that how that PC1 to PC2 sends a frame. Now let's see how does this switch learn MAC address. Now you will understand very easily. A switch does not magically know everything device connected to it. It learns MAC addresses by looking at the source MAC address of incoming frame. Already I told that this this source MAC addresses incoming frame through, it will take that MAC addresses to save into switch, then after it will save that. So here ping will get means if you ping means this ping will go here, and not ping that frame, ARP frame go here, then it will save the this PC MAC address here and this PC MAC address into there. Then after that requested sender to all ports. Now then after this port will receive, this switch port will receive that, then it populate its own MAC address based on the destination MAC address. Then it's know that is PC IP address, but MAC address not get here. So it sends a its own frame to switch, then both MAC addresses saved in switch. Then after it will know, switch knows which MAC address is dedicated from which port. Then after send ping means it will know where to where send it. That's it. Simply it's a golden rule type. Switch learns the source MAC address and uses the destination MAC address make the forward decisions. You understand? I mean, based on that source MAC address, then based on the destination IP address and MAC addresses, it will take that forwarding decisions via switch. Next. Mm. Next, knowing unicast, unknown unicast. Simply, for the now PC1 know the PC2 because already switch MAC addresses are here. Switch MAC addresses already sorry, PC MAC addresses already learn this switch. So if you ping from PC1 to PC2, it will directly know unicast through knowing unicast because switch knows this switch this IP MAC addresses which PC dedicates, then it will completely send from here to here directly. No need checking or anything, no need broadcasting. So like that. Wait, I will explain. Here you can understand easily. Like if PC1 is a MAC address, PC2 is BB 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 MAC address. So switch first take this entire both PC MAC addresses. It will take that MAC addresses, save in own MAC address table, like switch table, MAC address table like FA 0/1. That port means it's AAA like this MAC address, and FA 1/1 MAC address is BB BB BB. So this switch already have MAC address. Now PC1, if you try to ping to PC2, it's no switch already. So directly send, no need to broadcast it. It's directly send to PC2. So same thing. If you take in same thing, if you take in same thing, so but PC switch don't know. This is the first time. the this is the first time. So PC1 have a MAC address, PC2 have MAC address, but switch don't know that PC2 MAC address is BBB. So it's sends from all ports through broadcast MAC address. So broadcast MAC address means FFF dot FFF dot FFF dot FFF dot, sorry, column FFF. So it will broadcast it. I mean that the switch floods the frame out of the other. I mean like that switch, I mean సింపుల్గా చెప్తాను అర్థమయ్యేటట్లు. స్విచ్ అనేది ఆల్రెడీ తెలిసిన ఒక మ్యాక్ అడ్రస్ పంపితే అది నోయింగ్ యూనికాస్ట్. ఇప్పుడు తెలియదు కాబట్టి తెలియని దానికి పంపడానికి ఇది అన్నోన్ యూనికాస్ట్. సో జస్ట్ వెయిట్ ఎ సెకండ్ గైస్. Okay, so I mean it's don't know that MAC addresses like this is BB means before they know. If it is CC means so it's don't know that MAC addresses. So it's try to enter in this VLAN. It sends to broadcast it all switches to that MAC address finding for purpose for unknown unicast. సింపుల్ అబ్బా. యూనికాస్ట్ అంటే ఆల్రెడీ దానికి తెలిసిన, ఐ మీన్ ఆ స్విచ్లో మ్యాక్ అడ్రస్ లెర్న్ చేసుకున్నది అనుకోండి. సో అది ఈజీగా సెండ్ చేస్తుంది విచ్ డెస్టినేషన్కి అనేసి. బట్ అన్నోన్ యూనికాస్ట్ అంటే దానికి ఆ మ్యాక్ అడ్రస్ అనేది ఆ స్విచ్ టేబుల్లో లేదు. సో లెర్న్ చేయకపోవడం వల్ల త్రూ బ్రాడ్కాస్ట్ ఫ్రేమ్ ద్వారా అది కనుక్కొని ఆ డెస్టినేషన్ అడ్రస్కి సెండ్ చేస్తుంది. దట్స్ ఇట్స్ సింపుల్. ఓకే, నెక్స్ట్ wait just next broadcast. Simple. A layer 2 switch floats broadcast frames within the broadcast domain in a VLAN broadcast domain. In VLAN class, I will explain more about broadcast domain, because in VLAN only we can understood broadcast. Why using broadcast domain? Simply you understood that broadcast domain means if you send any data frame to switch, in entire VLAN it sends to broadcast the data frames. I mean if a switch first sends a data from first port, its switch is 28 port switch. So switch is total 28 ports. For expect that first port, remaining all ports it sends the data within the VLAN. I mean if you send say VLAN 1 data, sorry it's it okay, uh, VLAN 1 is default VLAN, leave it. If you send say VLAN 20 data, then switch know that entire all VLAN dedicated to which ports, then send broadcast it all VLANs. సింపుల్గా చెప్తాను చూడండి. ఇప్పుడు ఒక స్విచ్ ఉంటుంది కదా, ఆ స్విచ్కి 28 పోర్ట్స్ ఉన్నాయి. 28 పోర్ట్స్ ఉంటే ఒక ఎగ్జాంపుల్ తీసుకుంటాను, ఒక్క నిమిషం. సింపుల్గా ఇప్పుడు ఈ స్విచ్ ఉందా, ఈ స్విచ్ మొత్తం 28 పోర్ట్స్ అనుకోండి. అప్పుడు ఈ ఫస్ట్ పోర్ట్కి ఈ పీసీ అనేది డేటా సెండ్ చేసింది. సో రిమైనింగ్ 27 పోర్ట్స్కి డెస్టినేషన్ అడ్రస్ అనేది తెలియకపోతే బ్రోడ్కాస్ట్ ద్వారా బయటికి పంపుతుంది ఫ్రేమ్స్. ఇవంతా ఫ్రేమే. సో ఈ డేటా ఫ్రేమ్ అనేది ఇక్కడ ఎంటర్ అయినాక ఈ పోర్ట్కి తప్ప, ఐ మీన్ ఇది ఇప్పుడు సపోజ్ ఎగ్జాంపుల్ ఇది ఒక 10th పోర్ట్ నుంచి పంపుతుంది అనుకో, 10th పోర్ట్ తప్ప రిమైనింగ్ అన్ని పోర్ట్స్కి బ్రోడ్కాస్ట్ ఐపీ అడ్రస్ ద్వారా బయటికి పంపుతుంది. సో బ్రోడ్కాస్ట్ అంటే వన్ నుంచి మెనీ అనమాట. ఐ విల్ ఎక్స్ప్లెయిన్ దట్ వన్ ఆల్సో. So now next multicast. Multicast is one to many. Sorry for that broadcast. Multicast means multicast is one to many communication, but only interested receiver should receives the traffic. The exact forwarding behavior depends on the switch configuration and multicast handling. అంటే సింపుల్. ఇప్పుడు వన్ టు మెనీ అంటే ఒకటి నుంచి ఎన్నిటికైనా పంపుతుంది. బట్ అది డిపెండ్స్ ఆన్ రిసీవర్ ట్రాఫిక్. అది రిసీవ్ చేసుకునే ట్రాఫిక్ బట్టి పంపుతుంది. రిసీవ్ చేసుకునే ట్రాఫిక్ యాక్సెప్ట్ చేస్తే సో ఆ మల్టీకాస్ట్ అడ్రస్ అనేది పంపుతుంది. స్విచ్ కాన్ఫిగరేషన్ అండ్ మల్టీకాస్ట్ హ్యాండ్లింగ్ ఇట్స్ డిపెండ్స్ ఆన్ బిహేవియర్. మల్టీకాస్ట్ అడ్రస్ కోసం ఫ్యూచర్ క్లాస్లో మీకు ఇంకా బాగా అర్థమవుతుంది. ఇప్పుడంటే జస్ట్ మీకు యూనికాస్ట్ బ్రాడ్కాస్ట్ గురించి అర్థమైతే చాలు. ఈ జస్ట్ రిమెంబర్ దట్ యూనికాస్ట్ is what broadcast is. Unicast means 1 to 1. You send a data from 1 to 1. Already know that reverse data PC1 to PC2, PC2 to PC1. They already know the data, so it's unicast. Broadcast means if your 28 ports are there, means if you send one PC to another PC, but that PC MAC addresses switch don't know, so it's broadcast. Broadcast means it sends in the receiving port, expect receiving port, it send remaining all ports. Okay, got it? Next, simple and simple, just remember perspective. Unicast means 1 to 1. I mean one PC to one PC, one switch to one switch, one router to one router. Just I just for when I explained. Okay, next broadcast. Broadcast means one to everyone in the broadcast domain. I will explain that in VLAN time very briefly about that broadcast domain, because as of now VLANs I'm not touching, that's why it didn't get properly. Just understood what is what. One to everyone in broadcast domain, like if that entire switch has VLAN 20 means receiving port expect remaining all ports, it's broadcast. Broadcast means sends that frames. If it is not in that VLAN 20 means it won't send to that, it go to another port, like that. Multicast, one to many interested receivers. If that receiver is waiting for multicast address means it will send and it will receive. If it is not interested mean that multicast address sended but it won't receive. That's it. Okay. Next one, this is the most important topic, guys. Interviewer also asked like these questions. What is collision domain? What is broadcast domain? Collision domain. Collision domain and broadcasting domains are completely different concept. Broadcast domain is about how far a layer to broadcast can travels. Mm, simple understanding about every switch port represent a separate collision domain. Each switch port is separate collision domain. I mean in a switch per port have one collision domain. Broadcast domain and broadcast domains are completely different. Okay, broadcast domain is the group of devices that receives a layer to broadcast. Mm, I will explain with the example you can understand simply. If you take a if you take a hub means if you send one data like three pieces, if you one printer, if you have a three pieces, one printer is there, so you send a PC1 to print it. Okay, it's go and print will get out. If you send a PC2, then also will get at a time PC1 and PC2 send a data means it will collision in collision domain. Okay, you understood? In collision domain. Okay, in collision domain will happen in hub. If a switch means it won't collision because every port have a one collision domain. So that port knows it is collision domain. So it won't allow that collision domain to in that into that port. Okay. Broadcast domain already know. A broadcast domain is about of where L2 layer 2 broadcast can travel. I mean, already I told that broadcast frames are sent to all frames. That's called a broadcast domain. That's it. In VLAN time, I will explain that very deeply in broadcast domain. Just understood collision domain. Collision domain and very simply, you watch a journey movie na, that two buses crash dashed into face to face. That's the called collision. In name it is collision. Okay, so the data also same like that will happen, that both datas will crash into face to face. That's meaning collision. In hub it is not intelligent, so it sends whatever data from PC1 to PC2 PC3. The two devices give at a time print means the data will collision. If you same thing do in switch means it will first send a one data from to printer and that another collision domain it won't collision because already port has collision domain. So if you enter that port, it's wait for some it will go via one by one back, then it will go to there. Broadcast domain you could understand like that for example, a switch PC1 PC2 PC3. If PC1 sends a broadcast domain, the switch floods the broadcast to other ports in the same VLAN. So if for suppose that switch PC1 PC2 as in VLAN 10 and PC2 PC, I mean like if you take another PC like PC3 is in 20. So if you send a broadcast domain means within the VLAN I told, so it won't send to VLAN 20. Simple. Wait, I will show one diagram, you will understood very easily. Just imagine if it is a switch means VLAN 10 have PC1 PC2 same like VLAN 20 have PC VLAN 20 PC3. So if you send say PC1 to broadcast domain means PC2 will receive, but it won't send a message frame to PC3. That's it. The broadcast domain sends within the VLAN. It won't send to other VLAN. That's simply understood. Okay. Next, okay, final small practical lab will practice means. Okay, let's take switch configuration. I'm not explain anything now, so that's why I will explain here one thing. Okay, first if you whatever it is switch, wait, I will explain that practical thing also, real time also I will explain. Wait, take Cisco switch. Mm, let's take this because in my office it has, that's why. Copy the ms and go paste it. Okay, take very, these are business series mostly used in access layer. Already in one video I explained how enterprise networks or data link networks, leaf networks, how that networks are designed like that. Whatever it is organization, whatever it is industrial purpose, they have one core layer, one distribution layer, one access layer. That access layer completely uses L2 switches. If anyone asks in interview questions, in which layer using access, I mean, which access, I mean, which layer uses that switches access layer like that. They asked means you just told that it's access layer means here it is console cable. Wait, I will zoom. Look at here. This is console cable. You just already I did done one video. Just go and watch there how switch connected to here. One console port is there. Look at here, these are two console ports. This is RJ45 console cable, this is universal pin console cable, Y8 cable you call sanam pin charge andam kada, that type. So this is RJ45 console cable. Here you put that RJ45 console cable and another end connect to PC, another end connect to PC with USB or whatever it is. Then you just go to putty. I have putty. You go to putty. Here you can go to serial, then go to device management ports, go to device managements. Here I'm not connected now, so we can't appear here. Yeah, look here, it was not there. Same like now see Bluetooth link com3 like that. One HP console cable or whatever it is that based on that. Wait a second, guys. Power.